All right, so I'm going to dive in today. We've got a jam-packed, exciting agenda that is coming up today. So I don't want to waste any time. We will start with a welcome. We've got 3 wonderful speakers happening today. We have Edmonton Transit Service, Winnipeg Transit, and Halifax Transit, all talking about their fuel cell bus landscape and kind of either where they're at or where they plan to be. So we also have a Q&A that's going to happen after. I encourage you to use the Q&A function or add it to the chat if you'd like. We'd love to have a really robust conversation with these 3 individuals. And then I will do a very brief conclusion to this series that we have had, followed by ending the meeting. So I want to launch into this webinar today by acknowledging that I am actually located in Chibuktuk in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. And beyond just a land acknowledgement, CUTRIC likes to have some other initiatives. I've got that on the screen there. Feel free to take a moment if you'd like to learn a bit more about what we do besides just land acknowledgement. So jumping directly into our presentations today, I'm actually going to turn the virtual stage over to Derek to get us started.
Perfect. Thanks very much, Jess, and nice to see everybody today. For those that don't know me, my name is Derek Hansen. I'm the Director of Transit Fleet Maintenance with the City of Edmonton, and I'll be walking through the City of Edmonton's hydrogen initiatives and strategy this afternoon. So next slide. So Edmonton's a city of just over 1 million people located on Treaty 6 territory. And based on our projections, we're anticipating population growth up to upwards of 2 million residents by 2040. What I'll be showcasing today is our public transit hydrogen transition program. Our system covers 125,000 kilometers every day and enough to make a trip to the moon and back 58 times. We do over 87 million rides a year, which was pre-pandemic levels, and we're on track to see full ridership recovery this year. The transit system today is just under 1,000 buses, which includes 40-foot buses, 60-foot articulates, and 30-foot community service buses, and then paratransit cutaway buses as well. Next slide. So this highlights the journey that we've been on as a city to address our carbon emissions for a while now, and from a policy and operations perspective. So our transit journey started roughly in 2019 when we purchased our first 20 electric buses, and they went into service in August of 2020. And at the same time, we adopted our city plan and our transportation and municipal development plan solidified our city's commitment to climate resilience with goals to increase the number of trips taken by transit, foot, or bike. In 2021, we implemented our bus network redesign based on extensive engagement. We developed a new bus network to better serve Edmontonians, which we were rethinking the way that we look at transit in Edmonton. And that same year, we received federal funding for an additional 20 new electric buses. We also began a project through Alberta's Emission Reduction Alberta initiative to purchase 2 hydrogen fuel cell electric buses and put them into revenue service. So the City of Edmonton received one of those buses, and then Strathcona County received the other buses. They arrived mid-year in 2022, along with an additional 20 electric buses that we received last year, bringing our total electric bus fleet to 60, which is one of the largest electric bus fleets in North America. We also submitted to the federal government for a new transit garage and released a request for information to industry in the fall of 2022 for a hydrogen fueling station. And in April, we released an RFP for that hydrogen fueling station. Next slide, please. So to understand how we got to hydrogen buses, we have to take a step back and take a look at our program objectives. So where it started, the creation of our GHG plan for the city and meeting the goal of carbon neutrality by 2040. With our journey to 2040, we look to understand what it takes to get to a full fleet conversion and meet those goals. We asked a lot of questions around what does it mean to transition and plan to achieve this outcome. What infrastructure considerations do we need? We started to look at what is required to support that conversion to a green fleet. What are the operational impacts? What does it mean to operate these vehicles in a cold climate? And finally, what does electrification mean in the northern climate when we get temperatures upwards or downwards of minus 20 degrees? Next slide. So our fleet electrification journey started with battery electric buses. And just so that everybody knows, we park all of the buses indoors, so we don't have the challenges of having a mix of fleets indoor and outdoor. So we built a specific program of elements that we believe to be important to our operations, and we wanted to avoid having a fleet within a fleet, giving us that flexibility of our operations and cost control. We wanted long-range buses. We find range critical to the success of our program. We wanted scheduling flexibility. We felt that time is money, and we wanted really propulsion agnostic operations. So back to the point of not creating fleet within a fleet. We made a decision to go with fully in-depot charging, so no en route charging. And I believe we were one of the first to do this seamlessly within our garage operations. And we went with top-down pantograph chargers, which is save us footprint, and we accommodated these into our new garage designs as we had a garage that was in flight being built at that time. Next slide. So what did we learn in evaluating whether we're meeting our GHG targets on time? We're looking at the speed of the transition, the goals set out by our GHG plan and our conversion by 2040. And we asked, would we be able to transition fast enough with 1,000 buses in the fleet? Taking a look at our infrastructure considerations, there is a significant investment in infrastructure, a large footprint required at the facility level. We had to evaluate our grid capacity as well within the fleet, and we do have restraints out here in Alberta. A 2 megawatt feed into our main facility here where we have electric buses, we're able to charge around 14 at a time without tripping our breakers. So we have 50 electric buses at one garage and then 10 at another garage. And then we also were taking a look at what were our intended program outcomes, such as the range of the vehicles, and we were seeing the impacts of cold weather on the range of our battery electric buses, which then pushed us out to our goal of being propulsion agnostic. And we found that having 60 of 1,000 battery electric buses within our fleet to be manageable, but with moving towards a full fleet of electrification, we were looking at having to actually increase the size of our fleet and labor pool to cover the same amount of work, and then what the tax levy implications would be of going in that direction. So we then took a further look at infrastructure growth capacity and fleet diversification, what impact we would have on cost effectiveness and return on our fleet, the procurement of new vehicles and infrastructure of the operations, and all at the same time achieving our GHG reduction goals. Next slide. So why hydrogen and why now? So within the Edmonton region, there's an emerging hydrogen economy. Edmonton is uniquely positioned to be a global distributor of hydrogen. And at the City of Edmonton, we focused on supporting this transition. We are good at emerging markets. Oil and gas has been in Alberta for a long time. Boom is not foreign to Alberta, and we understand how to handle this. And we also have expertise in the hydrogen sector through our petrochemical sector. So we believe we're uniquely positioned as a leader in this space. So the fuel cell when we looked at our bus, the fuel cell technology has come a long way, and the conversion of our fleet offers us an opportunity for the city to build up the demand of hydrogen and show the world the success of this sector. Again, this is not new technology, and we've had hydrogen available in the Edmonton region for some time now, so we're not reinventing the wheel. And it allows us to meet our program outcomes. So hydrogen technology has the potential to help Edmonton meet its emissions reduction targets. The fuel cell technology can be used in transit, heavy-duty trucking, and other sectors to reduce emissions and improve air quality. And the adoption of hydrogen technology in Edmonton can help to create a more sustainable and livable city and help meet our city's growth objectives of 2 million people. And at the same time, we're looking at how we can meet these objectives. So the Emissions Reduction Alberta opportunity and the Alberta Zero Emission Hydrogen Transit Committee then enable us to accelerate these objectives. Next slide. So this is a highlight of the Emissions Reduction Alberta opportunity and the stakeholders that were involved in supporting this program. It's a collaborative project where the City of Edmonton is a project lead, but there are a number of partners that are listed there that have really made this possible, including Emissions Reduction Alberta, the Government of Alberta, and Canada Low Carbon Emissions Fund, Transition Accelerator, providing the industry expertise, HTech for project management, and the Power Cubes. Suncor is supplying the fuel, AMTA is providing integration opportunities. The University of Alberta is doing a ton of data collection for us right now. And obviously the New Flyer bus in Ballard for bus deploy and fuel cell. And of course, our transit operators, ETS, Strathcona County, and then Calgary and Banff are also partners on this project, and they'll be piloting our buses during the course of this project. So it involves a demonstration of 2 hydrogen fuel cell electric buses that will go into service here shortly. We're just waiting for the fueling station to be finally commissioned, but we're getting quite excited about that. And it did involve some facility retrofits at one of our facilities to accommodate the maintenance of hydrogen vehicles. Next slide. So this is just some background on the bus that we are using for the project. So it's a 40-foot New Flyer Excelsior with a Ballard fuel cell, range of upwards of 480 kilometers. And we've been doing a lot of testing and independent testing on this bus that's showing us some really great positive results, especially in the winter climate. So over the last year, our primary focus was on employee safety, training, and infrastructure requirements. And we did have our facility commissioned actually just in the last couple of months, which included our exhaust ductwork, ventilation, and hydrogen gas detection systems with audible alarms, anything that you would need to, I guess, retrofit a building and accommodate hydrogen. Again, HVAC is a main consideration, being able to circulate the air when required. Next slide. So this shows some preliminary testing once we've got the bus on the road, and we've been so in the meantime, until the Suncor fueling station has been commissioned, we've been working with Air Liquide and getting a low pressure fill. And so it's been a great interim step to allow us to do some testing of our buses. And we've been comparing the hydrogen bus to the battery electric bus to a diesel bus, and the temperature for our testing actually went down to close to minus 20 degrees Celsius, and we've loaded our bus with 3,000 pounds of sandbags during this time to emulate passengers on the bus. Next slide. So this again shows some really promising results for us. So the size of the tanks on the bus to accommodate hydrogen are 37.5 kilograms. So this shows us, when you do the math, that the bus will have a range of, we believe, up to 420 kilometers, which will certainly meet our program objectives and needs. I'll go to next slide. I'm just mindful of time. I don't want Jess yelling at me later. This just shows some energy consumption, and as we're comparing the diesel bus to the battery electric bus, and you'll see the energy consumption is actually the lowest on the hydrogen fuel cell electric bus. Next slide. So where does this leave us now, and how do we transition our fleet? So our ultimate goal down the line will be energizing buildings with hydrogen, but for now, it all starts with a 3-pronged approach, focusing on public transit, which includes the hydrogen fueling station, fleet conversion, and then a future transit garage to be built and operational by 2027. Next slide. So we find the fueling station to be the cornerstone of our conversion plan. We're looking at volume, which will dictate the transition and speed, public and private access, so fuel not just our buses, but public demand as well, long-haul trucking. We're looking at our southwest location at Centennial Garage as being the primary location with its access to the Henley and long-haul trucking there. There's also the potential for future hydrogen to be pipelined into that facility. We're looking for a partner, someone interested in building out the hydrogen economy in the Edmonton region. And we view this as over $1 billion program, and a lot of conversations around chicken and egg with hydrogen. And we've taken the approach that we want to be the hydrogen chefs. Again, our RFP for this fueling station will close in April. If you go to next slide, and we're looking for a vendor to provide an end-to-end fueling station solution, build, operate, and maintain. Go to next slide. And this is just an overview of the vehicles that we will need to convert. So obviously some concern there in terms of the age of our fleet and the number of vehicles that will be at end of life very soon. Next slide just shows an overview of our conversion plan that includes the new facilities and how we intend to have a swing garage to accommodate eventually a fully electric or hydrogen facility or zero emission facility. Next slide. So we're really looking at a 10-year window to capitalize on the use of hydrogen, being dubbed as the hydrogen gold rush, allowing us to expand our municipal fleet and facilities as well, not just on the transit side. And again, just to reiterate, we see Edmonton as being a world leader in hydrogen producing, and the fueling station as being the catalyst to our transition program. So I wanted to thank you all today, and I'll pass the mic over to, I believe it's Erin.
Wonderful. Thank you very much, Derek. And next up, we have Erin Cook.
Thank you, Jess. So first slide, Erin Cook, I'm sure most of you know me as chair of the committee here. Just wanted to give an update today on sort of the status of our fuel cell bus program. Next slide. So what we are buying, we took a pretty broad scope to our procurement. So the contract that we have with New Flyer to purchase up to 150 zero emission buses over the next 4 or 5 years gave us flexibility to purchase 40-foot or 60-foot buses in either battery electric or hydrogen propulsion. So of that, the immediate plans for our first several years of that contract is to target around 25 40-foot buses and 4 60-foot buses. But this is constantly changing, as most cities in Canada, we are sort of adjusting, trying to get our ridership levels up, and it may mean some changes in what we purchase on sort of an annual basis. The buses that we'll be getting are New Flyer's latest and greatest generation, which now have a 100 kilowatt fuel cell, same amount of fuel as that's on the Edmonton buses, but updated propulsion system, updated battery packs, and the new fuel cell. Range is still expected to be around the same, maybe slightly better, in the 300 to 450 kilometers per day. These buses will only have all electric heat, no diesel auxiliary heater on both the 40s and the 60s. So we're curious to see how that's going to work out, particularly with the 60s. We've mapped out our fuel cell buses to basically run on our longest routes so that we could prioritize battery electric buses charging once a day. And this worked out to about an average of just under 24 kilograms per day on our 40 foots and just over 36 or so kilograms on our 60 foot. So the buses are equipped with both TN1 and TN5. For most of you, that probably means nothing, but it means that we can fill the buses at a very high rate. We are including a IRDA sort of wireless communication protocol with these buses that allows, having to not deal with wires in order to enable fast fueling. We are currently expecting to get the buses in Q3 of 2024, partially for our ask to delay them because of delays on our fuel station procurement, which we'll get into a bit later. But next slide, please. For fueling, we have no massive source of hydrogen near us, unlike Edmonton. So there's been a lot of projects sort of in development and discussion here, but we couldn't wait for those projects to take off. So we have decided to proceed with building our own hydrogen station, including both production and dispensing. So we have an RFQ out right now, which is closing on Monday, as a first step in our RFP process for a design, build, construction of a production and dispensing station with approximately 500 kilograms per day of capacity. The intent is to carry about 1,000 kilograms of high pressure hydrogen on site and storage so that we could sort of expand this capacity weekday versus production on weekends. We don't know long-term whether we want to maintain or operate this ourselves, so we've decided to proceed with at least 2 years of maintenance and operation contract with this build, and then we reevaluate sort of after that time on whether we feel this is something we'd take on or continue to outsource. We will also be requiring station monitoring and performance, both for us to be able to optimize the system as well as some of our reporting requirements for our funding. Right now, we are targeting, hopefully, fingers crossed, to have this station operational by the end of 2024. Next slide, please. Partners that we are working with. On the funding side, we were fortunate or unfortunate, I guess, to still have Infrastructure Canada, Investing in Canada, Infrastructure Program, Public Transit Infrastructure Stream Funding, very long title, but it's a very good program, about 40% federal funding, 33% provincial funding, and the balance made up by the city of Winnipeg. So that was able to cover both the buses and the infrastructure, as well as a number of accessory costs that we'll talk about on another slide here. On the contracting side right now, I said obviously we'd name New Flyer on a separate slide, but in relation to the construction of our station, we're currently working with the Center for Transportation and the Environment for developing the technical specifications and RFP documents for the station. And we've hired Colliers to support the project management contract administration of that construction going forward. And then hopefully later this fall, we'll be able to announce partners on the construction and equipment and other things associated with that. Next slide, please. Some design considerations for on-site production. So there were a few sort of challenges with proceeding with this, biggest being footprint. It's a pretty big station, even for small capacity. This we are putting on a spot that takes up about 12 or takes away about 12 parking spots in our facility. Has a, the equipment has a setback from a certain building, but we were able to sort of align it with some sort of roadway that was already there, so hopefully save some costs there. But it is a site that does not have power or water to it right now, so we still have to bring it to that despite being a developed site. Power requirements, we're targeting like around a 1 megawatt station, but there's all kinds of additional power that's still required for all the accessory equipment, compressors, etc. So your 1 megawatt station actually needs about 2 megawatts of power. This station, despite the size and cost of it, is still, it's designed to operate only 12 to 14 buses at 100% utilization. That would be full to empty every day. Based on our planned utilization, that could actually be stretched out to support 20 to 25 buses operating 24/7. Estimated cost for this when we started the project was somewhere between $8 and $9 million, depending on how much storage we kept on site. But with inflation, we're expecting that to increase beyond $10 million. So we will know more in another couple months, but that's kind of where we're sitting right now. This station, even at that price point, was still not designed with a whole lot of resiliency, partially because we didn't have power to support additional production, and we are trying to cut costs as much as we could based on the fact that we're initially proceeding with only 25 to 30 buses, so we'd have a large number of diesel buses to back them up if the station were to go down. Next slide, please. Some other cost considerations. This is our outdoor fueling station will have some cost challenges associated with it. Development of a brownfield site, probably a little bit less than a greenfield site, but still construction is going to be required to dig and trench and pull up and interrupt service, outages and whatnot. The footprint eliminated revenue generating parking. We are forced to pay for parking here, not free parking. The site is a 0.6 kilometer drive, I think, from our parking garage, from where our fueling site is. So there will be some additional time, resource allocation that we have to contribute, about 2.5 hours a day, that will have somebody driving a bus and not either fueling or operating. And then there's the fact that we can't combine fueling with other services. Today, we will fuel the bus, top up fluids, sweep out the bus all at the same time. But because this is in a remote location, we might not be able to combine all of those activities, and we'll have to double up time. So compromise for a 30 bus project. On the service and maintenance side, the picture you see here is actually the bay that we've selected to upgrade for our hydrogen service. So this is a 60-foot bus bay that can fit 2 40-foots as well. So this will be upgraded with hydrogen gas detection. We'll probably need some HVAC upgrades to increase air exchanges, ensuring that there's no flame open flames and no sort of heat sources within the 18 inches of the ceiling. We also have to replace the doors with rapid roll-up doors. And then any service that takes place outside of this will still result in having to defuel the buses. So we have one room that has a dyno that still had some cutting and torching. So that would be a no-no for hydrogen bus service maintenance. So you may have some cost of just venting hydrogen to atmosphere. Next slide, please. So cost considerations, this is kind of an overview of Manitoba. We have a very low cost of electricity, standardized flat demand charges, which does make our cost to produce relatively low. So just sort of some estimates of what costing will be here. It's around $3.15 to produce the hydrogen. With it being on site, there's no delivery costs. And whether we are operating it ourselves or paying something to operate it will vary by, a couple $100,000 per year. Clean fuel credit, hopefully coming soon, announced, but not a lot of details on it, but expect to be somewhere in the $3 range, which could bring our costs down to incredibly low values when you're not considering CapEx built in. Some of the other costs we had quoted to us for similar systems, but not owner operated, or we had contracted for hydrogen as service, brought the cost up with delivery and other things to $7. And hydrogen as a service to produce fuel on site with all the markups was more like 15. That required additional resiliency built into it, compressors to make sure that you met your service level agreements, etc. Next slide, please. So where we're going in the future, we've announced, multiple times we have this a goal of 70% long range battery electric and 30% fuel cell. But I just wanted to highlight that that's not really the entire story of what our plan is. It's actually a very different story depending on which garage that you're at. So hydrogen is, like I said, will make up sort of our longest runs, most energy consumption routes. So on our 50 or 60 foot buses, it's more like a 50-50 split across. And that's distributed across multiple garages to make sure that if we were to have an outage at one building, we'd have sufficient service to cover with vehicles from the other facility. And part of this is around sort of optimizing, electricity usage in the province, trying to be as efficient as possible and trying to balance that against operational simplicity of having fuel cell buses that fill quickly, can operate longer ranges and whatnot. So we're trying to create a balance and part of our sustainability goals going forward. So hydrogen's part of our service requirements as well as our resiliency requirements as well. So that is all that I have for today. So thank you very much. And we'll pass off to Amir.
Thank you very much, Erin. Wonderful. Amir, it is your turn.
Yeah, at the beginning, thank you, Derek and Erin, for sharing this valuable information. I'm pleased to see that you are ahead of us in the journey of hydrogen adoption. I'm confident we will get the expert advice when we reach that stage in the future. Also, I would like to thank CUTRIC to organize this important webinar. And for those who do not know me, I am Amr Sami. I am Sustainable Fleet Analyst at Halifax Transit. I am a member of the team responsible for overseeing the transition of our fleet from conventional fleet to zero emission fleet. Additionally, my role involves assessing our infrastructure readiness and conducting research in this area. In the following slide, I will present an overview of the crucial role hydrogen plays as a sustainable fuel, which is undeniably necessary to achieve our goal of achieving zero emission by 2050. Following that, I will discuss Halifax Transit progress in adopting hydrogen fuel cell buses and briefly touch upon the challenges that impeding the scaling up of hydrogen usage. Lastly, I will share our short to midterm goals with you. So Halifax Transit operates a mid-size fleet of 460 buses, including 47 paratransit buses, which operate from 2 transit centers, along with 5 ferries. In June 2020, Halifax Regional Council adopted Halifax, and Halifax is a community response to the climate crisis to support the government of Canada's commitment to transition to zero emission by 2050. We announced our first unique electrification project to reduce greenhouse gas emission through electrification of 60 electric buses. First batch to be delivered this fiscal, and the second will be delivered next fiscal. Also, a deep power retrofit for our existing facility at Ragged Lake Transit Center. So, as you may know, Atlantic Canada is an important spot when we talk about hydrogen initiatives. Here in Halifax Transit, we noticed the momentum and anticipated a potential scarcity of green hydrogen at the beginning of next decade. We have seen here the Atlantic Hydrogen Alliance has been created to support the development of green hydrogen chain, signing the Canada and Germany Hydrogen Alliance. And the good news is there are a couple of projects to produce green hydrogen have already kicked off. In Transit Center here and in Halifax Transit, we closely monitor these developments to develop proper action plan for us in the future. There is no doubt the cornerstone of this transition lies in the energy cost and the pressing need for a substantial rise in renewable energy source. This increase in renewable energy is crucial to drive down the cost of electricity to the level where generating hydrogen or charging battery electric buses become economically viable and attainable. Next slide, please. So hydrogen fuel cell buses present a solution in the pursuit of zero emission transportation. With zero tailpipe emission, they hold great promise for reducing environmental impact. However, we shouldn't drop down or ignore the importance of consider the upstream emissions associated with their production and delivery. One notable advantage of hydrogen fuel cell buses is their extended range, which is comparable to diesel ones. This attribute is crucial for achieving a complete fleet conversion to zero emission fleet, especially when we consider the harsh weather condition, long routes, and extended operating hours. Moreover, hydrogen fuel cell buses require minimal maintenance due to their fewer mechanical components, leading to potential cost saving. Another advantage is their quick refueling time, 10 to 15 minutes, enabling efficient operation, reducing downtime. And overall, hydrogen fuel cell buses offer a viable and practical solution for transitioning to a greener and more sustainable public transportation system. Next slide, please. So here in Halifax Transit, we closely monitor the shifts in the local marketing demand for hydrogen. We want to ensure that our perspectives and plans are well communicated with all stakeholders, both locally and across Canada. And there is an important point here. Here in Halifax Transit and through our discussion with many OEMs, subject matter experts, and potential hydrogen suppliers, we notice how it's difficult for them to build their business model, as there is a lack of information about how the demand will look like in the midterm or long term in the future. So we are keen to share our views, plans, and expectations. Hopefully it will help even a little to forecast how the demand would be in the future. And as you may already know, in January 2023, Halifax Transit released feasibility study on supply, storage, and utilization of hydrogen, along with hydrogen fuel cell buses. As a part of our future plans, we anticipate deploying hydrogen fuel cell buses from our upcoming transit center located in Burnside. Next slide, please. So once again, the role of energy cost will be crucial in the transition to a green fleet, as it exhibits negative correlations with the cost of hydrogen production. As the price of electricity decrease, it will not only lower the production cost, but also to facilitate the attainment of desired scale we aim for, because our problem is how we scale with the production of green hydrogen. And I believe we are all agree that building a business model, whether you are a transit agency, suppliers, OEMs, are really hard, especially when the inputs you rely on are not well identified. Specifically for that reason, we have issued our feasibility study to try to minimize the impacts of unknowns, like how the demands would look like in the future, what hydrogen source is near to us. The form of hydrogen delivered to our facility, is it gas, liquid? Is it safe to have the hydrogen fueling station indoors? HAZA could allow that one. What is the optimal ratio between battery electric buses and hydrogen fuel cell buses? And since I mentioned the codes and the gap between the technology advancement and the corresponding codes and regulations, I would like to quote the recommendation from NRCan Hydrogen Codes and Standard Gap Analysis Project, published in April 2022. Right now, I'm quoting. They said the recommendation, following the review of the provincial regulations and directives, there is a little reference specific to design, construction, and installation of hydrogen equipment and systems. There are gaps in the provincial regulations and directives in relation to most hydrogen applications. To fill these gaps, the following is recommended from the regulatory authorities. Clearly define the term gas to include or disinclude hydrogen from the regulations. Adopt CAN BNQ 1784 standard as a main standard for installation of hydrogen equipment. Adapt other standards as necessary to cover design, construction, and installation of all hydrogen applications. Provide more directives specific to hydrogen applications such as hydrogen liquefaction, productions, appliances, power generation, indoor equipment, etc. Next slide, please. Next slide, please. No, before that one. Okay, there are one missing, that the short and mid-term plan we have here in Halifax Transit. So it seems there is one page missing. I can speak for it. So at the beginning, our short-term goal is to assess our current status and readiness to operate hydrogen fuel cell buses. So we have looked for our facilities. Do we have the footprint required to have any kind of infrastructure related to the hydrogen? And as we have heard in the last conference in Toronto related to that topic, most of our colleagues say they have a problem with the footprint. We have a limited space. So first thing came to our mind, how to assess our current facilities. Of course, we have released that feasibility study to conduct an analysis regarding the economic, environmental related impacts on if we adopt the hydrogen, return of investment calculations. Also, it's important to us to gain insight into the environmental impact and the potential reduction in carbon footprint associated with operating hydrogen fuel cell buses. We need to know the total cost of ownership, and we need to know what is the risk associated with adopting this technology. We need to educate our team, and we learn and know more about the maintenance requirements, as we are not far away in our journey to adopt the hydrogen. We need to ensure our upcoming transit center design and build as a flexible fuel facility that capable to accommodate various fuel options, and finally to operate hydrogen fuel cell buses from that building. Then I will move to the conclusion. I would say in our zero emission journey, we anticipate that hydrogen will play a vital role. The rapid drop in electricity cost will further accelerate the widespread and adoption of net zero emission buses, which is maybe could be battery electric buses, or maybe in mid-term to long-term hydrogen fuel cell buses. And hopefully with the continuous of collaborative approach we have today, transit agencies would be able to find a reliable hydrogen supply next door and seamlessly operate hydrogen fuel cell buses. Thank you for your attention, and please feel free to contact me if you require any additional information. Thank you.
Thank you very much. So next we will move into a Q&A opportunity. So I'll get my panelists, if they could, just to bring yourselves back on camera here. And Derek, I'm actually going to start off. I see you answered a question that came into the chat. So I'm actually going to give you an opportunity, if you're okay with it, just to maybe read that back if you still have access, and give that answer out loud, just to share that with the other folks.
Yeah, so thanks, Chris, for the question. It's tough to say in hindsight 2020 what we would have done. I think like I said in my answer, we definitely have the benefit of aligning our conversion strategy with investment and opportunity in the Edmonton region. So that's been a driving force behind the direction that we're going, both from an infrastructure and a fleet conversion perspective. In saying that, though, with nearly 1,000 buses, we would likely be open to testing a number of different propulsion systems and technologies to assist us in moving forward and converting our fleet. And so as long as there was an opportunity to access fuel, which is, the biggest challenges you can imagine, we probably still would have done a trial. We have experience in, doing a trial with hybrid buses in the past. And about a decade ago in Edmonton, we had a compressed natural gas trial of 2 buses. Again, not successful for us at that particular time. So I think just given our history and openness to adapting and trialing new technology, we probably would have still gone that way. To the extent that we're going right now, without that investment in the region, it's difficult to say.
Thank you very much, Derek. I would encourage anyone who has additional questions, you can either type it in the chat and we're happy to answer, or if you want to add it in the Q&A. So while we're getting a few questions queued up, maybe what I would ask is kind of a rapid fire of, at the stage you're at now for each of you, what would you say is like your top lesson learned? So if somebody who's considering this at maybe just a planning stage, something that they could factor in at this point that may, save them a bit of an impact by a hard lesson learned, that may be something that you found. And I'll let whoever wants to go first to jump in.
I'll maybe just start and say, challenging to navigate at first the codes and standards, but I think I would encourage people to reach out to some of us, get a better understanding of the feasibility studies that we've done, an understanding of the NFPA2 coding and national codes and standards from the infrastructure side.
Yeah, I would say also build a network. Said we are cutting edge in Canada, but there are a number of transit agencies, particularly in the US, who've already started this journey. I know, Derek and I are in conversation and we're starting to build a little Canadian hydrogen community here as well. We tend to not get the support behind all of the battery electric projects, but there is a lot of knowledge that can be shared, and we're all at different stages of the journey here, as Amr highlighted, and he said there are certain things that we can learn from each other just from the different stages that we're at.
Yeah, I just want to add that we have to keep maintaining open communication and channel, since it's all new. It's new for us. Maybe you are ahead of us, maybe 2 steps, but still it is new for all of us. And as I said, adapting a pilot program to operate hydrogen fuel cell bus, it would look like costly, expensive. So no need to take for small scales or for mid-size scale transit center. Maybe it would be a little bit hard to have a pilot program, but maybe 1 pilot program or 2 pilot program across Canada, the output of that pilot program could be shared and mimics in other province. The other things I have learned now, the cost of energy is really crucial to drive the cost of hydrogen down. So we speak about 10 cents per kilowatt, maybe here in Nova Scotia, maybe it's different in West, but really it is really crucial. And we have to, you can't do it alone, and service providers, agencies, private sector, they have to work together to scale up with hydrogen production and make a momentum for that one.
I think the other thing, just not being judgy of what other people are doing, right? Everybody's local economy is different, and everyone has priorities of what's being pushed on them. I think of the last, meeting that we had in Toronto there, the highlight was most of us are going into this because we're being told to do this from a regulatory standpoint. And so, a lot of the drivers that we're getting on hydrogen too has local pressures. So Alberta has a large hydrogen economy today that they're trying to green up through carbon capture. That isn't necessarily the case here, but I think at the end of the day, transit agencies are using zero emission vehicles. So like less of the conversation needs to be of where that source is, and more of it needs to be is getting a source that can be used for transportation in general. And we can work at the decarbonization down the road.
Eric, I think you might be on mute.
I was just going to say, I completely agree, and well said, and probably something that's not been said. Let's not be judgy of how other agencies are converting their fleets. And I think it's easy to do.
Wonderful. Thank you. And then, so I don't see any other questions coming in, so I'm selfishly going to throw a few myself. So if somebody else again has anything, feel free to drop them in. I'd like to talk maybe about facilities and how hydrogen buses are going to impact changes in your facilities that maybe you haven't had with a BEV or a diesel, that maybe something that could be of interest to folks. And again, I'll kind of let that be whoever wants to answer first. If this is something, maybe it's not something that you've had a lot of thought into at this point, but I have a feeling that you all have.
And I think Derek touched on a little bit with that authority having jurisdiction being the big unknown right now. Like as we start going through our gap analysis, we can look at NFPA2 as kind of the starting point, but then you always have that unknown of what your local fire department or fire authority is going to bring in after the fact. Like we've talked with, like the exact same fire code is interpreted differently by different cities. So that's kind of the challenge when you're trying to budget for projects. Just sort of, we're kind of breaking ground. Like there is no other or minimal hydrogen projects that are taking place in a building in our province and most provinces. So a lot of these projects are fairly new, and even when you're talking to people, they might not have been involved in the previous project that happened 5-6 years ago. So you know, there's kind of this knowledge gap that still needs to be built. And that's kind of, you have to be a little bit flexible in what your project is. So yes, you need to plan for things that you do know, but be prepared to budget for some of those unexpected costs that are going to come up.
And I think I would just add that, you know, understanding other agencies might have different systems. And so one of the things that we learned in Edmonton is the difference between an F2 and an F3 facility, where if you're doing just storage, there are different requirements or less requirements than if you're performing maintenance on a building. So it might be an interim solution for some transit agencies to just have a facility where you're storing hydrogen vehicles and not performing any maintenance. If you don't have the HVAC systems in place, your alarm system, the upgraded electrical systems. But one of the things that we've found through our studies is there's actually less of a footprint on the facility once you get those retrofits in place to be able to accommodate than there are for our battery electric infrastructure to support the battery electric buses.
Yeah, I think flexibility is important there too. Like you might not have to go all out. Like if this is a trial of 30 buses, how much do you really want to invest? So like we discovered we were looking at our gap analysis, missed our dyno where we, you know, do our tire alignments, where sometimes we do grinding. So therefore we'd have to fully update that facility, which is like 60, 70 years old. And we're like, oh my God, what are we going to do? And then we're like, okay, well, how often do you actually do a tire change and need an alignment? They're like once a year. Okay, so maybe we vent hydrogen off the bus. Yeah, we're losing a couple $100, but would we spend, you know, $10,000 a year venting hydrogen versus doing like a $1.4 million update? So, you know, some of these costs can be weighed off, just sort of understanding what your actual operational needs are.
Okay, and for that, right now we are in the stage of release an RFP to design our Burnside transit centers, and we are in the line between how the pressures will look like over the consultant. With the information we have right now, the consultant he has to design flexible fuel facility. So we are between two lanes, like exaggerating in the design, make it more safe and adding more cost to us and more money to invest. Or maybe on the other hand, maybe the code will change and ask for more modifications, and this will add more money to us to do modification for just a new building. So like this, I would say, need collaborative approach from subject matter expert across Canada, at least to minimize the changes coming over the time when you build a new garage or make like modifications for the old buildings.
Yeah, you ask one consultant, you get one answer, ask a second consultant, you get a second answer. So it is frustrating.
I agree. We've walked through that as well. And sometimes you need to identify those key consultants that, you can work with, are going to give you the best advice. The other thing that I would just add is do a full analysis of your program and your infrastructure. I could say for the new shiny hydrogen fuel cell bus that we received, the leadership in our organization thought that the best bit would be in our brand new facility where we have our electric buses, and we actually have it stored at one of our oldest facilities in an old, it wasn't an abandoned paint booth, but we weren't using it. And so because we knew that paint booth would have the HVAC requirements to support that bus, it's one bus, storage and maintenance. It's not always that sort of big shiny building. It might be another solution within your storage and infrastructure needs that best suits your program, depending on if it's a trial or the scale of your project.
Yeah, I think also bring a lot of diverse opinions when you're making this. Like, we were also looking at a paint booth, but when we brought in a group for brainstorming, we actually found another location that we hadn't really considered before that was an even better fit. So just, not working with just planners, making sure that you're bringing in your actual, a cross-functional team and getting a diverse amount of opinions.
Including your frontline staff.
Yeah, also add to that the proper mix between battery electric buses, hydrogen fuel cell buses, and of course we will have the remaining fleet from diesel buses. So when you design the new facility like ours here, how you will anticipate these numbers, how you will build the design criteria to have all this mix. So this also is challenging for us right now.
Wonderful. And then for a close, I'm going to throw a bit of a different question at you all. If funding was not an issue, if you had unlimited funding and fuel supply was not an issue, and that includes electricity or hydrogen, whatever color, what would your fleets look like in, let's go with 2030 as just to give you a little bit of an outline. So money is not an issue, fuel supply is not an issue. What would be kind of the dream fleet for you? I'm just curious.
If none of that was an issue, we would be 100% hydrogen. Like, it just is a drop-in replacement operationally, but that's never the case, right? Like, we have to balance energy efficiency. We don't want to, again, we're a green hydrogen province, so every time we use a less efficient hydrogen, that's taking away or possibly building another dam. So, this was the immediate question I got was, when I presented this to a First Nations community, and they're like, okay, well, if you're using less efficient energy, then, that might mean that you're putting a new dam in my property, and, that's destroying our community. So you have to be cognitive of that balance. If we're bringing it in from somewhere else, that's a totally different story. But yeah, operationally, yes, but you still have to be aware of all those other issues.
I'll jump in and say we would, because we've got 60 battery electric buses, I would say we would be 94% hydrogen and 6% battery electric.
I think if the battery electric buses technology do not change the scene and have a new technology that allow us to charge it quickly and they are really cheap, I would say we have to go with hydrogen.
Wonderful. Thank you all. That was a very interesting round of answers, and I loved hearing all of the hydrogen, of course. So thank you all. This has been very, very informative. I'm going to jump into a bit of the next step for myself now on the series conclusion. So this was our 4th of our webinar series. And I'm just going to do a quick recap for you of the other series parts that you may have missed. So in session 1, we learned the readiness of the organizations that were in that session. We did a Zoom poll, and in their transition to hydrogen in the next 12 to 18 months, we had 55% of the folks who voted in that poll were not ready. 17% were in the planning phase, 17% were almost ready, and 11% were very ready. So at the next session, we actually were talking about should CUTRIC proceed with a FCEB joint procurement nationally for fuel cell electric buses and a green hydrogen supply. So the feedback that we received during that session when we asked this question was that a joint procurement would be valuable, supportive, and timing is good. The value in exploring a joint procurement and strengthen numbers for some of the comments. There were a few other comments around if it would be a value add or adding complexity to an already complex landscape. If there's an importance for a joint procurement with green hydrogen, and there's always that question around hydrogen color. And then the cost and affordability aspects in adopting this type of technology was flagged. So in our third session that happened, the last one on the 21st, the question that we asked was, what is your greatest concern about moving into fuel cell electric bus use? The majority of the respondents to that question, it was infrastructure costs, followed by green hydrogen availability. And then additionally, we had some questions around staffing capacity, and about 50% of the respondents in our last session said that they didn't have staff available. So there was no staff allocated to their hydrogen initiative. And then also we asked about hydrogen color and what color they would be in support of for a joint procurement. And we had a 78% response rate of green and 22% said other. And then the option there that no one actually selected was blue for that meeting. So we also did a fuel cell electric bus readiness interview, and we found out from varying agencies where they were in their readiness. And honestly, it was all the way from not started to well into the planning process and working on procurement, some of them even at this point, as you now know. And something that we had asked all throughout this was, how can we support? So where is CUTRIC's role in supporting? And what we really learned was there's essentially 4 areas that we really have, had the feedback that we are good at supporting. Educating was one, lobbying and advocating, and also doing that fuel cell electric bus joint procurement. So I'll close out our session today just with saying that in the coming months, what I would encourage is just to keep an eye on the things that we're doing. We're going to provide some more detail based on what we've received from this series of open webinars. And we would encourage our CUTRIC members will have a heads up on some of the initiatives that we're working on. And I would advise everyone to stay tuned and find out what the progress and the updates will be. So thank you all very much for joining today. And this will be available on YouTube. So I will share out the link after with some of our speakers so they can share that if they'd like. So thank you all very much and have a wonderful day.